population regression function. This regression function, as we learned earlier, the linear regression function where we have a dependent variable and an independent variable. We had discussed about this in our class. So when we have a dependent and an independent variable, and we are framing the econometric model as y is equal to beta 1 plus beta 2 x, we are explaining the relationship between two variables. So that is also known as a two variable regression model. Now when we collect data, when we are analyzing a particular economics situation or some social variable we are testing, we we need to collect the data. So the relationship which is mentioned, linear regression model is a tool. Now in order to check the relationship between the variables, the dependent and variable, data is required. So that is a tool that is available. So this population regression function, it is a regression of y on x. So you have the x variable, y variable, which is a dependent variable, and x is a independent variable. What is this term population means? We have studied earlier in statistics, where the entire population data set is taken into consideration. So if the population is some 1 lakh people, all the 1 lakh is taken into consideration. So the population regression line or a curve is a locus of the conditional means of the dependent variable for the fixed values of the independent variable. So this population regression line that we are going to frame. So when we do the linear regression model of this dependent and independent variable, from this regression analysis, we derive a regression line. How do we derive this regression line? We get the value of the constant, the intercept, and we get the value of the slope. So based on the value of the independent variable, that is the value of x, we will be able to determine the value of y, since we have got the value of the intercept and the slope. So how this dependent variable is changing with the change in the independent variable is what is the regression line. So I will show that in this slide now. You can check here. Yeah, this is the regression line. You can see this is the regression line. What is measured here? On x-axis we are measuring the weekly income. Okay, we are measuring the weekly income. On the y-axis we are measuring the weekly consumption expenditure, you can see. So this is measured in terms of dollars. Now when you do the regression, you will get the value of an intercept. This point where the line is starting is the intercept. So this is your beta 1, or sometimes it is also called as beta naught. But whatever the first parameter that comes is the intercept. Okay, and the way as the x value changes, so when from 80, when the income is increasing to 140, and then further it is increasing to $220, what is the change in the consumption expenditure that is observed? So this is determined by what? The slope coefficient value. So as the value of income changes, what is the change in the consumption expenditure that is observed? So you can see when the income is $80, the consumption expenditure on an average, because this I told you earlier, not all families with $80 as an income will have same consumption expenditure. So it will keep changing from family to family, it will change. So we are taking the average of it. So if there are some 100 families with $80 as an income, we cannot assume, or we cannot put a condition that all have to spend $65 only as a consumption expenditure. Some may spend 75, some may spend 79, some may spend 60, some may spend 55, some may spend 65, and so on and so forth. So but we are taking an average of it. Okay, average means what? We will add all the consumption expenditure divided by 100 people. So that is this conditional mean. So it is conditioned on what? It is conditioned with respect to the income. So given the income as 80 is the average consumption expenditure is considered to be $65. So that is what is the conditional mean. So what determines this population regression line? How do we determine this population regression line? It is the conditional expected value. Okay, conditional expected, why we are saying conditional expectation means what? Conditioned upon the income as a fixed. Okay, what is the average value of the or average change in the dependent variable that is happening due to the change in the income. So when income is changing from $80 to $140, the average consumption expenditure is changing from $65 to $101. So this is these points are nothing but the conditional mean that you can see here also it is mentioned. Okay, so let us go back to this equation. So now you will understand this equation better. Expected conditional E here is expected value of Y. What is Y? Consumption expenditure. Bar Xi means given the value of income. Okay, the conditional expected value of consumption expenditure given the value of income is a function of what? Is a function of the income. So only when the income is changing, the consumption expenditure is changing. So it denotes that it is some function. So this conditional expected value or average value of the consumption expenditure is dependent on what? Is dependent on the income. So as the income changes, only the consumption expenditure is going to change. So the equation here is a linear function of x. Okay, so this is represented as beta 1 plus beta 2 xi. So what does it explain? How the average value of the y is changing with the change in the value of the x. Okay, that is what is mentioned as the conditional expectation function or the population regression function. So that is what this particular diagram is explaining. So here we are assuming one example here of a population where you have around 678 people in that particular locality. So I have just given this in terms of rupees for your better understanding. So if there is a for example, there is one village where we are having a population of total population of the total population is sum of all this. So 325 plus 462 plus 445, 707 and 678. So this is the total population. Okay, so the considering all this the total, it is divided among different income groups and their respective consumption expenditures are being put here. So you can see there are 5 families here. One second, this total, sorry, I have made a mistake, please rectify. There is a family size here of n. This is what you have to look into. So 16 plus 4, 23, 29 families are there in this particular locality. And sorry, please make the changes. There is a families, there is a assumption of 29 families here, and their respective incomes are being taken here to be fixed as 80, 100, 120, 140 and 160, and their respective consumption expenditures are being given here. So a person with a 80 rupees income can spend anywhere like this, and he's spending, there are 5 families and who are spending in this particular order. In this order they are spending. There are 6 families with an income of 100, and this is how they spend, and similarly so on and so forth. Okay, so based on that we calculate the average. How do we calculate? 325 divided by 5, which is 65. 462 divided by 6, 7. This is for your understanding purpose. How do we arrive at this conditional expected value? This is for your understanding. You can change the data and you can put the data. Just remember the fixed income. You have to have a fixed income. Consumption expenditure you can change accordingly when you are illustrating and showing, but this is how it is calculated. Okay. Then coming to the stochastic form of the PRF. This is a very important concept where we have to understand that the population regression line which we have shown earlier, we have not brought the stochastic form of it. What does it observe? The stochastic form observes the difference, okay, but that is the average. You can see here average value is 65, okay, 65 for this in families with an income of 80, but not all are spending 65 rupees. Only one family is only spending 65 rupees. One is spending 55, another is 60, another 70, another 75. So the difference between the actual and the expected value, okay, what is the actual expenditure and what is the average expenditure, that is what is your stochastic form of a population regression function. Okay, so that is we are trying to understand that here. So the population regression line or curve explains that with the increase in the family income, consumption expenditure on an average increases. But when we look into the table, we can see that individual consumption expenditures does not necessarily increase with increase in the family. Not necessary that always increases. We observe that given income level and individual family expenditures clustered around the average. So it is something, it is around. It is either greater than or less than. So it is, there is a difference, variance in the average consumption expenditure. So the stochastic form here is represented like this. What I told you, the actual and the estimated or the expected, which I told you just now, is the stochastic form of the PRF. So this UI term represents that stochastic disturbance term, and this YI is the actual consumption expenditure minus E of Y bar Xi is nothing but the average consumption expenditure. So in this this particular equation can be written as Y is equal to this expected value is taking to the other side. So you have expected value of Yi by Xi plus Ui. Okay. So this expected value of Y given Xi is equal to is nothing but the beta 1 plus beta 2 X. That's how we get the expected value. So we are incorporating, since this is equal to this, we substitute that in this equation down. Since this is equal to this, we are substituting this value in this place. So we get this Yi is equal to beta 1 plus beta 2 Xi plus Ui. So where the deviations Yi is an unobserved random variable taking positive or negative values. Why? Because each family has their own way of spending. So that is the stochastic disturbance or the error term. Because why it is called as an error term means not always it is the average value is equal. Not always the consumption expenditure value is equal to the average value. So there is a discrepancy, there is a difference, and because of which only we get this stochastic difference form. So that is what is mentioned in the further slides. Also you can go through these slides, and I have given, see the example I have given for your better understanding. So when 80 rupees is, this is the UI, okay, the difference between, so when X is equal to 80 rupees, not everyone is having a consumption expenditure of 65 rupees. Some are having 55, some are having 60, 70, 75. So individual consumption expenditures keeps changing, okay, and that is why we have this. So we take expectations on this. This I will teach in the next video. Okay, this slide.